Topic focuses on nonparametric approaches to market risk estimation, emphasizing methods that do not rely on restrictive assumptions about the probability distribution of returns. Unlike parametric models, which often assume normal or log-normal distributions, nonparametric estimation allows the observed data itself to determine the shape of the risk distribution. This flexibility makes nonparametric methods particularly useful in financial markets characterized by skewness, fat tails, and volatility clustering. Historical simulation is the most basic example of a nonparametric technique because it directly uses past returns to estimate value at risk VAR. The program highlights that these approaches are highly intuitive and adaptable for practical market risk management. One major nonparametric technique discussed in the topic is bootstrap historical simulation. Bootstrapping involves repeatedly drawing samples with replacement from the original return dataset and calculating VAR or expected shortfall (ES) for each sample. The average of these simulated risk measures becomes the final estimate. Because observations are replaced after each draw, the same data point may appear multiple times in a sample. This method improves estimation precision relative to standard historical simulation by generating a distribution of potential outcomes rather than relying on a single ordered sample. The topic notes that bootstrap methods produce more stable and coherent risk estimates, especially when tail observations are limited or sparse. The topic also explains nonparametric density estimation, which addresses one weakness of traditional historical simulation: the discreteness of historical data. In ordinary historical simulation, VAR estimates can only correspond to existing observations, making it impossible to calculate intermediate confidence levels, such as 95.5%. Nonparametric density estimation smooths the empirical distribution by connecting histogram midpoints or using continuous curves between observations. This process creates a surrogate density function that permits VAR estimation at any confidence level. The approach preserves the overall probability structure while improving analytical flexibility. By smoothing the data, risk managers can better estimate tail behavior and obtain more refined measures of market risk exposure. Several weighted historical simulation methods are introduced to improve responsiveness to changing market conditions. Age-weighted historical simulation assigns greater importance to recent observations and less importance to older data using a decay factor. Volatility-weighted simulation adjusts historical returns according to current volatility conditions, helping avoid underestimating or overestimating present risk levels. Correlation-weighted simulation further extends this framework by updating both variances and covariances among portfolio assets. The most advanced technique, filtered historical simulation, combines bootstrapping with conditional volatility models, such as GRCH. This method captures volatility clustering, asymmetry, and changing market dynamics, while preserving the strengths of historical simulation. The program concludes by evaluating the advantages and disadvantages of nonparametric estimation methods. Advantages include computational simplicity, reduced dependence on covariance matrices, and the ability to accommodate skewed or fat-tailed data without imposing unrealistic assumptions. These methods also allow integration of advanced weighting schemes that reflect current market conditions. However, nonparametric techniques depend heavily on historical data quality and may fail to anticipate unprecedented market shocks or structural regime changes. Quiet historical periods can underestimate risk, while volatile periods may exaggerate future losses. Furthermore, the largest estimated loss generally cannot exceed the worst historical observation. Therefore, risk managers must combine nonparametric tools with judgment, stress testing, and complementary modeling approaches.